Hey, to LeetCode. Here we are. We're gonna solve this. We're gonna start off by solving this palindrome. I think this not sure. Oh yeah, two pointers thing. It's a two pointers problem, which means you're gonna have two pointers. It's easy. Let's create a folder. Actually, you know what? Hmm. What a palindrome number is. Okay. Get started. Palindrome. Okay. So the way we're gonna do is we're gonna have two pointers, one at the front and one at the end. And I'm gonna reach a middle point, then we're gonna stop. Okay. Two pointers, one at the start and one at the end. Okay, so this one should be quite easy. Let's start and one at the end. Slowly come up, slowly come towards the center and check if the string character are the same in two of the pointers. Back. Okay, that's good. Okay, so if that is the case, then we can check this one out. We can start at here. A, and let's have A, let's say it this way. A, A, the L, A, N, A, and then we both end up with C. And so if we keep on going and not decreasing, so middle point is good enough. Okay. Center is going to be s dot length. This is the length, right? So divided by 2. So we're gonna keep track of the length, and then start. Left pointer is going to be 0, and then pointer index. And the right pointer index will be, let's say, length stop -1. Okay. So we have left, let me go right. Well, no, first we gotta trim. Trim dot length. Hey. Trim string is gonna be s dot, here I am. Trim, then if trim string is empty, is empty, string true. Okay. It's empty, then return. Liter, hell yeah, I'm a liter. So the current problem that we're doing is this one, palindrome. A phrase is palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Okay. Which means this is a palindrome, because if you get rid of all the spaces and then you what do you call it, and then you check it and it's going to be the same even if you reverse it. Like if you reverse the string, it's still going to read the same thing. Okay. So what are we gonna do is, we have a couple of ideas, but we have to see if it works. So if it's empty, if we start off with an empty string, we just simply return true. We don't have to worry about anything else. Center is going to be trimmed dot length, and then yeah, so we have our left index. The way we are going to solve our problem is we are going to have 2 pointers, one at the left and one at the right. So they are slowly going to come towards the center, and every single time they're gonna check if the numbers match. Okay, it's like these, just like these, this. Okay, and then we are going to see that they're all gonna match, and ultimately they're gonna meet at the center. And when they meet at the center, then we can say that it's a palindrome, because we have checked both of the pointers, the left and the right, and both of them reached the center. And every single iteration, the character check was valid. So at the very start, we're gonna be here. Okay, and then both of these are going to be the same character. Then we're gonna move here, and we're gonna see that both of them are same character. we're gonna move to the third character, third point. It's also going to be the same. Fourth is going to be the same. 6, 7, 8, 9, 10. You get the gist. Ultimately, we're going to end up in the center, and yeah, we can say that it's a palindrome number. That one should be quite easy. So yeah, and if you take a look at this as an example, R is R common, A and A is common, C and C is common, E and A is not common. Okay? Yeah. Oh yeah, we also have to consider this kind of string. Where it's not possible to have a 1 2 3 4 5 6 7 8 when there's an even number of uh there's even number of characters. Okay, yeah, so when there's even number of characters, there's going to be two center points. This is going to be the center point. The left will have a different center point, the right will also have a different center point. Okay, so here we have once, in here we're gonna have two. Okay, so left center, let's call this one right center. Let's make it a little bit bigger. Yeah, the what do you call that, the right. And you know what, it's actually not this one, not that hard, to be honest. Like once you get the hang of it, right, once you know the pattern, you kind of get the idea. It's not that, like when I started off, I was pretty experienced in programming, but when I saw LeetCode, I was like, what the fuck is this? This is so hard. But yeah, as I kept doing, things started to look a lot more easy. Okay, so we have to check the length first. Length, right? Or length? Okay. So if it is a odd or even number, right? Okay. So we're gonna do int length. It's gonna be trimmed dot length. We're gonna store the length first. Okay. So if length %2. Wait. What am I doing? Left center is gonna be 0 for now. Okay. So what we're gonna do is, if length %2, this means we are checking the remainder. If we divide length by 2 and we get a remainder, that means it is an and we get no remainder, then it is a even number. So like when it's 7, %2 is equals to 0, then what we want to do is we can have, what is 7 divided by, let's see, 7 divided by 2, it's gonna be like 1 2 3 4 5 6 3, right? Okay, 3.5 basically, and then 7 6 5 5, and then 5 divided by 2 is also going to be 2 3 4 2, right? 2.5. So what's 2 3 4 5 3 4 5 3. As I kept doing, show your profile. Yeah, I mean, like, you know, before I even did this one, I found it quite hard, but now I think I have 10. But I think I did in my old account. You know, this is my new account. This is Kuchukborom. I think I have some other records in my other account, but I gotta check it out. How do I log out? I'm pretty sure I have some in my other account. I think I used Git or Kuchukborom. Because I'm pretty sure it's more than 10, or maybe not. They both point to the, what do you call it, the same thing. Yeah. Oh no, this is not this is not my account. It's Kuchimbormudi. What the fuck? Zero. Like I feel like I could swear I did stuff, man. Or maybe is it in my Git? I think it's linked with my Git then, because I remember I did quite some LeetCode. I think last year or something. I think not. Okay. I think 10 it is. I think 10 is what what I did. Nah, like yesterday when I saw, I was like, what the fuck? I just did 10? Feels like I did quite a lot. Okay, so this one is even number, right? Sorry, even number. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So when it's 8, we have to divide it by 2. 1, 2, 3, 4. Another 1, 2, 3, 4. Okay, so when it's odd, we don't have to do anything, right? We don't have to. Left center and right center is going to be the same. Left center is going to be what do you call that? Length divided by 2. Length divided by 2. Okay, and same goes for the right center. Right center can also be length divided by 2. Okay, but if it is not the case, then what we want to do is the left is going to be, center is going to be the actual value, length divided by 2, which is going to give me some value. I forgot what value is it gonna be. I think it was 4, right? 1, 2, 3, 4. Yeah, and then our right center is going to be left center plus 1. Okay, so now we have defined the center point for the left pointer and the right pointer. Now we want to keep on iterating both of them. So we want to iterate while let's say left, what is that? Left index, left pointer. That's how we haven't like specified this one. This one should be at the very top. Same goes for these. The right pointer index is going to be left is going to start at 0, which means here it's going to start at 0, and the right side is going to be the length length minus 1. So the length is 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 minus 1, 7. It's going to be here. And the reason we do a minus 1 is because the counting starts from 0. 0, 1, 2, 3, 4, 5, 6, 7. That's why, okay? And I think somebody hit me up on Discord. Or maybe not. Because why is the picture blurry? Oh, find common elements between two arrays. Oh yeah, I did this. I think I did this. I used what do you call that? Maps, I think. I think I did this in the live stream as well. You were there. But I'll check it out. I'll check it out again. I don't think people use, what do you call that, JavaScript for LeetCode, but it doesn't really matter because if you know the logic, right, you can do it in any programming language as long as you have an idea about the language. So we want to start off with while left pointer index is greater than or equal to, sorry, is greater than, sorry, the left is going to be 0, right? It's always going to be lesser than, yeah, lesser than left center, and right pointer index, so it's going to be, it has to be greater than the right center. Okay, so let's based on this, let's see how we can do things. We're gonna check if s, and then we're gonna do left pointer index is equal to sorry, it's trimmed. It's gonna be left pointer index is equal to trimmed, and then there's gonna be right pointer index. So we are comparing the left and the right. If they both are the same, then we can continue. It's not equal to, okay, we can just do it's not equal to, then return false, right? If the current character on the left and the current character on the right, they're not the same. So if this character and this character are not same, then we are just going to return false. But if they're both same, then we're going to increment the left pointer index is going to be plus plus, and then right pointer index is going to be minus minus, because right side has to come this way. The right side has to come this way, right? So we have to decrement. It's 7. In the next position, it's going to be 6. Next position is going to be 5. And for the left side, it's going to be 0. Then it has to be 1. It has to be 2. And then it has to be 3. And then, yeah, that's it. So it looks good to me. And then if you reach here, then we can return true. So let's copy this. And then let's go over here, paste it, and try to run this. Let me open the door for my docs. S.trim. Oh, we are doing it in C#, C++ again. Fuck C++, we're gonna do it in C#. Solution does not contain a, okay, it's palindrome. Okay, okay. It's gonna be S palindrome. Accessibility especially low. What the fuck do you mean? Was it supposed to be public? What do you mean, bruh? Okay, this is correct. This too is false. Man, plain. Come on. Oh, we are supposed to get rid of this kind of symbols, you know, this comma and all of these things. We see. Okay, so we need some string manipulation as well to get rid of commas and this kind of characters. Let me just copy this. I find it much more fancy to work in IDEs. Okay, so let's see what cool are the docs. UT. Nice, man. You can't even type, you retard. Okay, so this one's looking good. So now under string manipulation, we have to write trim string dot. Okay. Is there any easy way for string manipulation in? I think we can just build a string builder. String builder is gonna be new. Okay, so we're creating a new string builder, and what we're gonna do is for each var s, var v in s. Okay, so we're gonna iterate everything, and what we are gonna do is if char dot is ASCII character is alphabet, it's letter. Oh, dot. We can do a dot lower. To lower. That's letter, and it's gonna be v. And then string builder dot append. We're gonna append v. Can we build or something? Do string. Okay. So we have the string, right? we are, oh my gosh, I want to sneeze. We are iterating the string, every single character, and checking if it is a ASCII character. If it is an ASCII character, then we are appending it. That's it. Okay, but just to be sure. No.
এই কিন্তু ni pompa semni porikha bo maths ka kono sangane ne tuition ram sum tong ta na da 10 12 din ko por de ta
na lagi na baka sa mami na sawa na
na se class kai ne
this return true. Why though?
ta ho ta
So its center point. Let's see out. Let's print to see what's the. Let's print to see what the final string is, right here. Okay. So this one's gonna be into the right line. So let's do a. I think it's supposed to be L. Yeah, this one is supposed to be L. Capital L. I want to know what RACE, race a car, right? RACEACAR. Okay, this is correct. RRAACC, and then this one. Okay, so this is where it's failing. I think my logic is kind of flawed in there. The center point is going to be 1 2 3 4 5 6 7 8, right? So 8 divided by 2 is going to be 4. So the left side is going to be 1 2 3 4. Oh, wait, with center points, yeah, set it as 4, and then this is going to be 5. 1 2 3 4 5. Okay, 1 2 3 4. 1 2 3 4. So this one and this one, right? I think we don't need this 2 center points. If we have it at 4, we have it at 4, right? 4 as our center point, so it's going to be 0 1 2 3, and then it's not going to do this. So if we do this, it's going to be 7 6 5 then 4. Yeah. Left center, right center. So it can be up to 4, up to 7 6 5 4. So equal to minus 1. It can be up to here as 7, right? So 7 6 5 4, and then it has to be 3 again. And then this is 0 1 2 3. Then this is 7 6 5 4. Okay, so it's not even maths. It's just me being a retard. So this one's gonna be, I think, right's gonna be minus 1. I'm not sure. It's just my guess, though. Because this means that when we are here, right? We're checking if left is less than the center. The center is going to be 4, right? So 4 is going to be somewhere around here. So it's going to be 0 1 2 3. It's going to go up to here. And for the right side, our index is going to be 3. So 0 1 2 3 up to here. So we're going to be 7, yeah, 7 6 5 and then 4, and this one is not gonna get checked. Okay. Okay, now this is still fucked up. This one is valid, of course. This one is also valid, of course. This one is not valid. Okay. We'll just do it here itself. The left is as long as it's less than the center, right? So 4. And as long as the this pointer is greater than Or okay, right center. What if we do an equal to instead of the left one? I mean, it's accepting, but I want to know why. Let's also print out the yeah, so it works, but let's print out the indexes as well. Let's do, and then left center is equals to let's say left center, and then right center is equal to right center. So we're just printing out the centers. So left center is 4, right center is also 4. Okay. This is when it's even, right? 1, 2, 3, 4, 5, 6, 7, 8. Why is right center 4? What the fuck? Left center is length divided by 2, which is 4. Then when we do the, I think this is the one, is equal to 0, yeah. If it's 0, then we are dividing it by 2. I see. If it's 0, so it's even. I think I did the opposite thing in here. This one was supposed to be left center minus 1 or plus 1. It's greater than, right? So minus 1, and this one is gonna be just left center itself. Because if we are in an even number, for example, right here, we want the left to be on the like 4, 0, 1, 2, 3, 4, and then we want the right side to be on the, what do you call that, on here, on E. So this is gonna be 0, 1, 2, 3. Yeah, so this one should work. Not allowed in heaven. Okay, yeah, this works, and this is a bit more easy for my brain to wrap around. The previous one, right? It was a bit counterintuitive, because if I do greater than equal to, then both of these conditions don't really look nice. They don't follow the same rule. The left pointer and the right pointer, they don't follow the same rule. So I think it's much nicer to have this. So let's see if this works. No. Okay, 0 is. Let's print again, baby. Let's print. 0 should not be considered an alphabet. Okay, yeah, this one, right? Okay, right center is okay, it's 0. Okay, if the length is just 1, we are going to return false. Okay, this is just one single case. We can just do start printing, blah 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 blah. Where's the length? Where do we have the length? Length, right? If length LENGTH is less than or equal to 1, return false. Yeah, that's all we have to do. At least this test case is going to pass. I don't know about the rest. What the fuck? Expected true. Output false. Why is this supposed to be? Why is this true? What the fuck? What do you mean? Okay, I think what we do is we had to do a check in here. Counterintuitive. What does that mean? I don't know the meaning of counterintuitive. I'm from a Bangla medium. I'm not well versed into all these fancy English words. Okay, so if we are in A, then this is just gonna be simply A. So this is true, okay. But in the previous case, it was 0 and P. So this is technically 2 words, right? So we have to check the length, okay. If that is the case, then we can do if s dot trim dot what do you call that? So after trimming dot length, sorry, we have to get rid of that. Okay, huh? No, 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 no. We can't do this. Lower dot trim dot lower. Okay, it's ASCII character. No, no, no. That is such a tricky case. The 0p is such a tricky case because we get rid of length, right? Oh my gosh. Because if it is 0 and p, ultimately it's all going to end up as p, right? So this is valid. And the same goes for a. So we can do a before and after length check. So we can do it after and we can do it before. But I don't think that is a valid reason. Length check, right? It doesn't seem look valid to me. जाओ बेटा ट्यूशन जाओ बेटा ट्यूशन আমি কইরা দিব that's liar. They're allowed in heaven. Oh, so that's what you were talking about. La 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 la. Help, paradox, help. Help me, paradox. Help me, whoever wrote this test case needs to go to heaven. Like, if I submit this with no length check, it fails in here because 0 is not a palindrome number. And then, but P alone is a palindrome number, okay? So what this means is, what do you call that? This means that whenever you have a character like this, you cannot consider it to be a palindrome number. Okay? You cannot consider it to be a palindrome number. Even if ultimately this is going to end up as P, but you cannot consider it as palindrome number. So ultimately the string ends up as P. And this is not supposed to be palindrome. But if you have a string such as this from the very start, then this is considered a palindrome. Okay, it is fucked up because ultimately we are dealing with manipulated string. So if you want to do some checks, we have to do it before, and if you want to do it so we can do the previous and the check s dot trim if, so we can just do if s dot trim dot length. This is not gonna work because the length is always going to be different, dude. Is equals to 2 and what do you call that, final string, and the final string dot length. Oh, it's gonna be length. Length is gonna be this one. Length is gonna be this one. 2 and is equals to 1. False. I'm just hard coding a fucking answer. Just hard coding an answer, dude. A dot. This is also going to be return true. This doesn't make any sense. Like, you know, non-alphabetic, right? Oh, wait a minute. When they say non-alphabetic, non-alphanumeric, oh, so 0 is supposed to be there. Fuck, man. Or, man, I'm so stupid. Or is, okay. Come on, made them merge. Made them mera beja. Last function, if this is this. Last function, if this the length is equals to 0, return -1 of return. चल भूख लगा रे Meta mera beja. It's so hard to read in this format. We don't even need this anymore, you know? I just did not read the question properly. I should make a habit of doing that. So we just have to do some Bing chilling. We just have to do over here or is digit. Okay. So if it is a digit or a letter, we are going to add it. That's all we had to do. Yeah, decent enough, not bad, not the best, not the worst, but let's check out the solution of other niggers. Code in Java. Who the fuck codes in Java? So their approach is implementation to determine a given string is palindrome. If it reads the same forward and backward, this approach is two pointers, just like the one we used. We have 2 pointers, one at the start and one at the very end, and they move towards each other. And then oh, they don't even trim it. That's crazy, dude. I see. So they don't even do this section, right? We are doing this, right? They don't even do this. They are literally traversing this array right on the freaking spot. I mean, you can definitely go for that approach. So they have a while loop, and then they have their first and the last pointers, just like the one. And then they have their start plus plus and the scatter digit. Okay, so they're checking if it is a digit or a. Okay, yeah, we can definitely try this one, this approach. You know what? Let's try this one out. Let's do a second submission. This is not even clever, but yeah. Oh, fuck! There's too many mosquitoes. Okay, so the way they did this is they don't loop at all. They don't have any final strings or anything like that. They don't have this. They don't have any of these things. All they're doing is we just have a start, left index. It's gonna be 0, and then int right index. It's gonna be let's say s.length -1. Okay, so while true, so it's gonna keep on looping forever. We are going to write our own condition for exiting this. We are going to while, oh yeah, while left index is less than or less than equal to right index. So as long as they both are as long as the left index is less than or equal to the right index, which basically means as long as the left index is always less than the right index. For example, it's 0, it's 7, right? Ultimately, we keep on looping and we reach here, and this one here is going to be 0, 1, 2, 3, and this is going to be let's say 4, and then the next time it's going to be here, then it's also going to be here. Yeah, we are gonna use less than equal to. So the next time, I think you get what I'm trying to explain, right? Array prototype last is used to return the last element of an array. I see. That is nice. So, but we are going to check is the if char dot is digit is letter or digit. Okay, if the current is letter or digit, and this is going to be s left index. If we are not in, if the left pointer is not a character or a digit, so it is equals to false, then we are gonna left increment the left index. Okay, the second thing we are gonna do is if dot is letter or digit, we're gonna check, and now we're gonna check the right side. So right index false, then we're gonna update the right index as well, plus. Okay, so and then ultimately we're gonna do else if continue. So if this condition is true, we're just gonna continue. Okay, and then here we're gonna check if char dot is digit or letter, and this is gonna be as left index dot can we do a two lowercase? Two lowercase, I don't think we can do a two lowercase dot two lowercase lower is equal to char dot is letter or digit. We're gonna as right index, then we're gonna do dot to string, and then dot to lowercase to lower. So if the left and the right character they're the same, then we're gonna it's not the same, yeah, it's not the same, then we're gonna return false, because the current character that we are looping, it turns out they're not the same. But if we can loop successfully through everything, then it means that it's false. But if that is not the case, then we are gonna right index right index is supposed to be minus. Yeah, we are meant to decrease minus, and then left index is gonna be plus. I think the logic is flawed, but I'm too lazy to kind of you know what, let's have a dry run. Okay, anyone, if everyone explains, everything is easy. Yeah. So we have a while loop, we have left, which is going to start at 0, the right is going to start at the length -1, so at the last index. So we are checking right here. Okay, so this is going to be here, this is going to be here, we're going to check if this is the same. So what's going to happen is, why did I bring this up? What's good? Oh yeah, I can't move this. It's because it's a bug. So what we're doing is that we have this, we're checking if the left is a what do you call that, is not a valid. So this is going to be false, this is also going to be false, and this one's going to execute. They both are the same, R and R are the same, so it's going to return the same, right? So we're going to move on to this code, which is going to, the right side's going to be here, the left side's going to be here, and then we're going to move, and then we yeah, so it's going to be here. So the index right now is going to be 1, this one is going to be 6, something like that. I don't know the exact amount. Oh, you know what, fuck it, I'm too lazy to check. Dry running, not my thing, at least for now. Dry running, not my thing, at least for now. Also, why is it this fucked up? So this is valid, of course. This is returning true when it shouldn't be returning a true. This one is returning true, false. I see. Is digit letter or digit? I see. I think this is letter. ASCII letter is alphabet. What is this? It's ASCII digit. It's letter. It's okay. It's ASCII letter. It's digit, and then it's number. Or it's number. I see. Oh my gosh, this condition is gonna be so big if let's see, char dot is number and or char dot is alphabet is, what do you call that? Letter, right? Letter, yeah. I wonder what does digit really do. I'm confused. Is number, is letter. So this is gonna be s left index, s right index, okay, and we have to make sure that this is in a bracket, so it's treated as one single statement. And I'm gonna copy this, and I'm gonna paste this. What the fuck? This is supposed to be the left index, and this is gonna be right index, right index. If they're both that one, then we are gonna check if s left index the lowercase, is it possible to lower, oh my gosh, the string dot lowercase is equals to s right dot toString dot lowercase return false, and this is gonna be not equal to, okay. So if the left and the right is not the same, we're gonna return false, and we're checking if it is a number or a letter, okay. The fuck, disco थोड़ा बजल लगता है देखिए. Yeah, a bit, not much. Logic is not that hard, to be honest. I mean, for this, but yeah, we have to like try it run a couple of times to like check stuff out. Just kinda L for lead syntax तक खुजते लगे यार कि yeah. Damn. Whoa, baby. A rated prototype. Okay, the syntax is so weird. If this, the length is equals to 0, return -1, else return what? That's it. That's all you have to write. What is this? Array prototype last. Write code that enhances. Oh, this is a different one, right? Oh, I see. That enhances all arrays such that when you call array last method on any function, it return the last element. But the last is return -1. I see. If there is no element in the array. Nice. This is pretty good. Haven't seen this one. Yeah. 8-3 दूसरा खाली, so easy, yeah. Nice. Okay, why is this not working? I wanna print the characters. Which one is console.write line, and we are gonna do a left. I will just print, and then the right side. So the left is gonna be as left index, and it's gonna be right index. Okay, I want to know what are the characters that's getting right index doesn't exist. Right index. Okay, I want to know like which character is getting recognized and which isn't. So A is getting recognized, M is getting recognized, N is getting recognized. Okay, the P output false. I see. So A is getting recognized, M is getting recognized, A is getting recognized, N is getting recognized, A is getting recognized. Okay, this one right here, it's okay, I wonder what. I wonder what. I wonder why. Na 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 na. Okay, if we are here, then we do this. If we're here, then we do this. Is letter or digit is false. We're continuing. Then we are just gonna do. Oh, we don't even need this. check anymore. Yeah, we don't need this check because we're checking this at the very top in here. So left is gonna be here, right? It's gonna be here. But yeah, I wanna know what's happening. Okay, what the fuck? This one's working now. Dude, this is so weird. These codes, man. When they work, when they don't work, we can't even tell. Accepted beats 43%. This is even worse. Like the performance-wise, this is even worse than the earlier one. O of n, yeah. O of n because what do you call that? We have one loop, right? Just one loop. It's iterating as through the whole string, so it's just O of n. Yeah, this one's done. I wanna check my submission. Accepted, right? This one, yeah. I wanna check the time complexity of this one. Oh, so we can't analyze. So we can like analyze if our time complexity, that's complexity. We can't. Fuck you, man. Fuck you. I wanted to know what the time complexity and all this thing was. Anyways, okay, this is the accepted one, right? Why is this even worse? I don't get it. This one should have been faster, but we'll keep it. So we'll just write it here and put it here. It's gonna be the solution. Let's call this without manipulating the string. Okay, and then our second solution was yeah, this is the non-manipulated version. This is the manipulated version. Let's copy the function and paste it in here, and let's call it 2. That's gonna be with manipulated string. Okay, perfect. थोड़ा बेजा लाग्छ है देखिए always 1443. I forgot. This one's like 40% better, and this one, which I thought was going to be better, it beats for 14%. But yeah, so it's weird. Anyways, this one's done. We can move on to the next one. So which one is easy? Which one is easy? So we have sliding windows. So yeah, this is going to be. Oh, this is the one that me and Paradox. Sorry, me and Paradox one. Me and Focus did yesterday. Okay, so sliding window, right? I never did this. Sliding window is gonna be my first kind of problem. Oh, valid parentheses. I did this one. Let's solve the valid parentheses first. But the thing is, I already solved it, so we don't have to solve it. But basically, the way it works is, oh, you know about stacks, right? Stacks. Do you know stacks? Oh, you were there. Okay. So in China, I was there. Do you want me to solve the stack one? This valid parenthesis. I did this earlier. I forgot if you were there or not. Or did I even do it on stream? Okay, before that, it's best you know what a stack is. What? Do you know what a stack is? The bus. Nah, you have to know what a stack is. You have to know. Stack. What is stack? What is stack? A very short video of stack versus heap memory. Yeah.
Stack is very important and common data structure. Let's take a look at it. Akin to linked list or array, stack is linear data structure which contains a group of elements. Those elements are stacked on top of each other like a physical objects. If you want to add a new element to the top of the stack, we will use the push function. If you want to remove the most recent element, we will use the pop function. As you can see, the last element we added will be the first to come off, and the first element we added will be the last. This behavior is called LIFO, which stands for last in, first out. Stack has also other functions. With peek, we can access elements.
It's basically, you know, whenever you add items, it's going to get added on the top, and then whenever you remove an item, the topmost or the latest item that you added is going to be removed. I forgot stack. I forgot if we used stack at noon. Push and pop. Really, I don't remember. Anyways, so I don't know if C has built-in stack function. If not, we are gonna be creating it ourselves. So this is gonna be, what is this question called? Valid parentheses, right? Yeah, valid parentheses. So let's create new folder. Valid. Okay. Where's the folder? Where did I create the folder? What the fuck? Oh my gosh, I created it inside this. Well, parentheses, and we're gonna create a readme dot md. And then we can copy this thing and then paste this here. Given a string and then valid parentheses. So you know, what is a valid parentheses? A valid parentheses is when you open a parentheses, you have to close it. That's what it means. Okay, it's as simple as that. This is a valid parentheses. You're opening it and you're closing it. This is a valid parentheses because you're opening it, you're closing it, you're opening it, you're closing it, you're opening it, you're closing it. Another example is I'm going to show you another example. Okay, let's have a look at this a bit more complex parentheses. This is also a valid parentheses. We are opening it here, we are closing it here. We're opening it here, we're closing it here, we're opening here, we're closing it here. You get the point, right? This is a bit more complex example, but yeah, basically every opened parentheses needs to get closed. So that's what we're gonna be solving through stack, baby. Through stack. Stack is fun. I love stacks. Stack helps you to avoid recursion as well, which I hate. So this is gonna be a valid parentheses solve. Okay. So right here is our code. Let's copy this and let's have it right here. Okay. So let's say our let's use stack. Okay, and I'll tell you the reason why. We are going to use stack. Okay. So to give you an idea, think of this as our stack. Okay, instead of it being vertical, right? Instead of it being, you know what? Let's have a vertical stack to make it even easier. So this is our stack. This is our stack. Okay. So let's have our input, an example input. Input's gonna be, let's say I know,
Hello.
So we have this as our input, right? So we're doing this, right? So at the what we're gonna do is whenever we encounter a opening bracket, right, such as this or this or this, we are going to add it in the closing bracket. Sorry, so we are going to add it to the stack. So the first string that we encounter is going to be this one, right? So it's opening something, so we are going to add it right here. just like this. And then we encountered a closing parentheses, right? So whenever we are going to encounter a closing parentheses, we are simply going to pop whatever is in the stack that and it has to match the parentheses. For example, if we see a circular parentheses, I think that's what it's called, then we have to pop the top stack item, and if that stack item is a circular parentheses, then it is a valid parentheses. Okay, so yeah, and then so we pop it right here. It's because we encounter a closing parentheses. Same goes for this one. We encounter an opening one, so we add this one right here, and then we encounter a closing square parentheses, so we pop the top one, and then we check if the popped element is a square parentheses, and since it is a square parentheses, it's valid. Then we encounter another curly parentheses, so we add it right here on the stack, and then we encounter a closing parentheses, and so what we do is we just pop the top element, and we check if it is a curly parentheses. So the whole thing is valid. Okay, and a bit more complex example would be something like this. Let's something like this. Yeah, this is a bit more complex example. So the first parentheses we encounter is going to be our what do you call that, an opening curly brackets, so we are going to add it to the stack like this, right? And the second one, we encounter our circular brackets, so we are adding it to the stack as well. Perfect, right? And on the third one, we are encountering our closing bracket. So when we encounter a closing bracket, we're going to pop the top one, and then we are going to check if it matches up. So we encountered a circular bracket, and we popped a circular bracket as well, so they both match up, so it's valid. And then we see that the next element is also a closing bracket, and so we pop the top one, and we see that they both match. The closing and the popped element, they both match. So yes, we can say that it's a valid string as well. But if we have an invalid invalid parentheses, for example like this one, so we encounter this, so we add it to the stack, and then we encounter circular brackets, we push it to the stack as well, just like the previous one, and then we encounter a closing bracket of the curly and then we encounter a closing bracket, so we remove the top one, we pop it, and we notice that they don't match. We encountered a curly bracket, but we popped a circular bracket, so it doesn't match, so we return a false, yeah, that it's an invalid parentheses stack. Every time we encounter a opening bracket, we add it to stack. Okay, every time we encounter a closing bracket, we remove it from stack. Okay, we remove it from stack. We remove it from stack. We remove from stack and check. We pop the value from stack and check if the two brackets are of the same type. It is as simple as that. Okay, so firstly we need a map to store, we have to store like the relationship between all of the parentheses. Okay, so we are gonna have a dictionary, and this is gonna be of type char and relation, and we are gonna be having a relation right here. So I think we can just do this, right? So this is gonna be closing and can we do this? I don't think we can do that. Yeah, we can't do that. So we are gonna be creating a new, inside this we're gonna have this, and we're gonna have something like this. Let's say opening. It's gonna be closing. This is work. Okay, yeah. Maybe not. Does this work? Does this work? Maybe it does not. How do we add new elements to the to a dictionary directly? I'm kind of confused. I think this is how we do it. Okay, yeah, okay. This is how we can add elements directly while you are creating the what do you call that? The dictionary itself. So we are mapping it. We are also going to map this one, the squares, and then we forgot to add a comma. So it's gonna be here, and then we are gonna have the other one. So this one right here. Okay. So we have 3 of them. This is let's say open to close map. Then we want to create another one, a close to open map. The reason is it's nice to have 2 kind of arrays. This is going to be closing and opening. This is going to be closing. It's going to be the opening one. Okay, so we have 2 of these maps. So it's valid, right? So we want to iterate our string while s. Oh, sorry. Not these, man. Okay, int index. Okay, it's gonna be index is gonna be at 0, and what we're gonna do is while. I think we are gonna return. What do we return? Index is less than s.length. Okay, so we are gonna iterate through every single character. Okay, that's basically what we're doing. Or instead of doing this, well, we can just do a for loop. I think that's easier. Var v in s if what do you call that? Open the map that contains key. If it is a opening bracket, then we are gonna we need a stack. Fuck, we have a stack. So we need a stack of let's say char. So let's call it stack. Okay, we have a stack right here, and we have our dictionaries and everything set up. So what we're gonna do is we wanna add stack dot push. So whenever we encounter a opening bracket right here, we're gonna push it. Okay, so we're gonna push the v. Alrighty. So whenever we encounter a and then we are gonna check else if open close. If let's see if we encounter a closing. Else if we encounter a closing one, then what we are gonna do is we're gonna pop the top one. So var top parentheses, it's gonna be stack dot pop. So this is gonna give us the topmost element. Okay, and then we have to compare it if both of them match. If what do you call that? Close to map b is not equal to top parentheses, we're gonna return false. So you know the element that we just popped and the element that was closed, they don't match up. So you know in as I showed you in the example, when you are closing a curly bracket, but the latest opened bracket was the circular bracket. So if everything works well, we are gonna return true at the very end after the loop. I think there's like some few things that we have to look out for. Okay, instead of, I think we don't even need this. We can have that if v is, let's say this or this or this. I think we can just do this. We don't need this map because there's only three types of brackets anyways. So this should work. Let's see if this works. I think there's gonna be something that's gonna fail, or maybe not. Yeah, so this is false because this is opening, but we're closing a square bracket. We are opening a circular bracket, but we're closing a square bracket. And here, yeah, everything is working fine. This one is also working fine, but when we submit, we have to go through a lot of test cases. Okay, this one is returning true because this is never closed. Okay, so for this, we can just what do you call it? Return stack dot is empty length. What is there no size or something like that? Is empty? What the fuck? Is there no function for checking if a stack is empty or not? There should be, dude. It doesn't make any sense. There should be a function to check. Dot all append count count return. This count is equal to 0. So we are returning if the count is 0. So this one should fix that issue. We can just copy this line, and instead of returning true, we are checking if at the very end there is a if there's something left in the stack, it means that something has not been closed yet. Stack empty. What is this? Loss expected output. Which test case is this? I want to know. S is equals to closing, right? I see. I see. Closing. If contains key is this, then if stack count is 0, if stack dot count is equals to 0, oh sorry, it's gonna be is equals to 0, return false. Okay, we can try another thing. We can instead of doing this, we can try this. If stack dot try pop. So this is going to try to pop it, and it might fail. So what you want is out char current char, or maybe popped char. Okay, yeah. So what we can do is in here, if is equals to top parentheses, or else we're gonna return false. This is another neat feature of C#. This is why I love it. Like, you can try to do something, and if that something doesn't happen, you can simply return false. Yeah, this is lovely. This is lovely. This is lovely. Because without this, we would have to do this if stack count is 0 or something like that. But with try pop, we can just have a if statement, and this is going to be false if there's nothing on the very top. So let's run the local test just so that we know that it works. Okay, what the fuck? This is false. Okay, let's see what's happening. We're pushing this one. Then we are contains key. Then we are popping it close to this one. So we're popping it. And then we're popping it. Yeah, we're popping it, right? So we try pop, and we try to pop it. Oh, this one is supposed to be no. Try pop. Yeah, this is correct. So we tried to pop it, and we popped it, right? We popped it. We popped our character. So we push it just to be sure. Let's console print it. So the right line, and then let's just do V. We'll try to see the character that we are in right now. Good, hey, damn. Try pop. Yeah, try pop is nice. STDC out. So we are popping something. Oh, I don't think we popped anything at all. I think the better function is gonna be try peek. Peeking. Peek. Oh yeah, and peek is like you're checking what's on the very top. You're not popping it yet, so the item is still gonna be picked item. So what the fuck am I doing? So we are picking it, right? If they are the same, then it return false. Try peek. Then if we can pick it, then so we can have Then we can have a char popped. Char is going to be our close to open map, and we're gonna do oh no, we are gonna supposed to pop stack dot pop. Okay, see out, see out. Okay, you know what? I'm gonna do? I'm gonna do the if way. Yeah, we're gonna do it this way. Stack count is 0, return false if it's valid. Yeah. I don't know why the try pop did not work. It should have worked. This one, right? If it contains, then we're gonna try to pop it. Returns a value that is equal to true if none is present, and removes it from stack. Okay. Try pop, right? It returns a boolean, so it will be true or false. If this is real false. Ah, I see. Oh, this is gonna be else. Fuck me, this one was working. I'm pretty sure this one was working. I'm just gonna copy this. We just forgot to add it inside else. So what was happening was, without the else statement, right? Without the else statement, this if was this is going to be true, so this loop is going to, like, this body is going to execute, but after that, this is the next what do you call that, next condition, right? So it's returning false by default. This one needs to be inside else, so that this executes or this executes. Without an else, this one is going to execute, and then this one is going to execute on its own. So we have to make sure that we put them inside what do you call that, an else. Okay, this one is valid. Let's see. It's okay. I would say yeah. I'll take this as a win. With 6%. Okay, let's check out the solutions now. The solution, 2 ways to solve the problem. Let's have a look at the problems. Using stack. This is the stack method which we did. This is like the, what do you call it? Exact. This is gonna be the same.
The range is open parentheses.
Okay. Okay, the approach is like you map stuff and then and then this is the other way. On solution 2, we can solve the stack with stack only if stack has a parenthesis, because this is a Python, JavaScript. This is your favorite language. This is what it's gonna look like in your favorite language. Okay, yeah. I mean, it's same. This one, right? The, what do you call that? Where's my submission? This runtime, right? Runtime is very random, because just like in our computer, the runtime is going to vary every single run because of various factors. So this one is not really a good way to measure your what do you call that? Your code speed. A better way to measure your code speed is your this one, runtime complexity. Just like this one, right? The O of n, O1, O(n) square, stuff like that. That's a much better what do you call that, way to measure your complexity, time complexity and memory complexity. This one's like O of n because there's only one loop happening, so it's O of n. Okay, so this one's done. We submitted this, right? Just to show you. Okay, so the parentheses, this one is done. But did I do something wrong? No, I did not. What easy is left? This one is left. Best time to buy and sell stock, but I'm not gonna do this now. I'll try to see if there's something else. Binary search. Whoa, binary search is fun, baby. It's been so long since I did this binary search. So let's try this one out. Or you know what? I'm gonna do? I'm gonna try to do this one. This best time to sell stocks, because what do you call that? Because I don't want to keep on avoiding it. It's not gonna be good for me. But I have zero fucking clue how to do this, so I have to look at the solutions first. This one works, okay, but when we submit, this is not gonna work because the memory constraint is going to exceed. Yeah, this is like way too big, right? So we can't really use this. So we're gonna have this. Sliding window takes 3 of them and does something. I don't know what it does. So let's learn a little bit about sliding windows. Let me watch myself as well. Nah. Whoa.
Can you see me? Can you see her? Hi.
Hello.
Why are you cold?
Because I'm wearing nothing.
Well, you're wearing something. I mean, this is an outfit, isn't it?
Minimalistic.
Well, what are you doing?
I guess when we get
Cultured
the
man.
same thing.
Less, right?
Yeah, but no, I'm not like in a cold convention center. I'm like surrounded by
You
people.
want me to tell them to turn the heat up?
Yes.
Okay, it's like, do we know who to ask to turn the? It's kind of a big space.
It is a big space, and I need heat, please.
You need heat. Ooh, okay. So you are wearing.
I'm wearing Chun-Li.
Okay. Can we have a turn in your Chun-Li? So was this your concept, or you just kind of are wearing it?
So, I feel like Electra is more me, just because she's like a little bit cooler in like skill-wise.
Yeah.
But this, I think I look like her.
There exists a lot of problem-solving techniques, backtracking, dynamic programming, divide and conquer, and many other ones. Today we will discover an interesting one that can be helpful when facing some problems: sliding window. There is a shelf of books, and you're allowed to take 5 contiguous books for free. And because you just care about money and not if books are interesting, you decide to take the 5 contiguous books with the highest total price. You start calculating the total price of each group of 5 contiguous books. The first one is this one. Its total price is 12 plus 9 plus 23 plus 17 plus 25. You take some time to calculate, you find 86. Then you move to the second one. The total price is 9 plus 23 plus 17 plus 25 plus 19. What you're calculating, you find 93, a better total price. You move to the third one, 23 plus 17 plus 25 plus 9 plus 4, wait, you find 88, not higher. Fourth one, 17 plus 25.
I see, so that's it.
Person, the fast algorithm. Process before coming, does he calculate faster than you? No, he just used a fast algorithm. Based on does he calculate the price of 4 groups, there is another person that already found the best group and took it. How did he do? Did he know process before coming? Does he calculate faster than you? No, he just used a fast algorithm, based on the technique we're learning today. The mistake you did was that for each group, you was recalculating the sum from scratch. For the first subarray, you calculated 12 plus 9 plus 23 plus 17 plus 25. Then for the second group, you calculated 9 plus 23 plus 17 plus 25 plus 19. While the other person noticed that the difference between the first and the second group is just one element. Remaining elements are the same. Their sum doesn't change. So he took the sum of the first group, subtracted the element of the first group that is not in the second group, added the element of the second group that was not in the first group, and got the sum of the second group, without calculating the sum of all elements from scratch. In reality, the technique he used is called sliding window. Sliding window technique is a problem-solving technique that works by maintaining a window, a contiguous part of the data that respects the constraints. Then, we keep moving that window by extending it and shrinking it while respecting constraints until we finish the whole input. In our problem, the window represents one group of 5 contiguous books. We start from the first one.
Then to move to the next group, we slide the window by extending it from the right by 1 and reducing its size from the left by 1. We're interested by total sum of all potential subarrays of books, and our window will traverse them all. And to update its total sum, we don't calculate it again from scratch. We just add the price of the book that entered the window and subtract the price of the book that went out of the window.
Okay. Kinda got the idea. Okay, so to do that, we just need 2 right here. In our case, we are working with 2 variables. We need to calculate the, what do you call that? What the fuck is this? This is so big. Okay, in our case, we are working with 2 numbers because we have to calculate the maximum, the best time to sell and best time to buy. So we're just going to comparing this, stuff like that. So we're going to be working with 2 at the very max. Okay, max profit, right? So let's go back. Would be my, big thing is my cock, not yours, man. Yours is lightning cable. Parentheses valid syndrome. Okay, so let's go back here and create a new project. Sorry, a new this is like, what is the thing called? Best time to sell stock. Okay, best time to buy and sell stock. Let's create a readme. Readme.md. Let's have our okay, this is good enough. Let's create our best time to sell and to buy and sell stock. Solve. Okay, and then we're gonna have our solution. Anyways, Paradox, did you catch my did you see the, what do you call that, the sliding windows video, so that you kind of have an idea of what we are gonna do? Okay, so sliding windows. We need to keep a track of this number. Okay, why the fuck is this vector? Oh, we were at C++, not C sharp. Okay, so we want to remove that and we want to work with this instead. Turn 5. Okay, so what we're gonna do is, we have this, right? So we have a bunch of prices and we want to calculate the indexes. Okay, the indexes is 0 and 1. Okay, so let's have an index. Current index, it's gonna be at 0. Okay, so index is gonna be at 0. So while what? I don't know the condition yet, so I'm just gonna put in true. I don't know the condition. So what we're gonna do is prices at current index plus prices at current index plus 1. Okay, this is gonna be current price is equals to gonna be this, right? So this is gonna give us a price. Sorry, we were supposed to do a minus, if I'm not mistaken. Yeah, we were supposed to do a minus. So next plus 1, because we are checking the profit and loss, right? So if our, let's take an example of this one. Yeah, we'll take this as an example. So this is an example. What we're doing is 0 is the this one. This is the 1, right? So what we are doing is we're doing 1 minus 7. So if you buy at 7 and sell at 1, if you buy at 7, okay. What if we do this? Current minus plus 1. What does this mean? This means that we are buying it at this 7 and selling it at 1. 7 minus 1, 6. Okay, yeah, this is not. This has to be this way, yeah. So we are doing, what do you call it? 1 minus 7, which means that we are buying at Acha, you know what, to make it even more easier to understand, I think I should have separate bought at is equals to bought price. It's going to be prices, and it's gonna be, let's say, I, yeah, or index, current index. This is when we bought, and sold price is going to be prices current index plus 1. So now we need to int profit is going to be bought price minus sold price. I think this is easier to understand. So this is going to be bought at 7, sold at 1. So bought's going to be, okay, it's going to be the opposite. Sold price minus bought price. It's going to be sold at 1 minus 7. So we have our profit, okay. So now we need to implement the sliding window thing. So to implement that, we have our profit. So you want to have the max profit right here. And the max profit is equal to going to be 0. So we're going to check if profit is greater than max profit, then we're going to update the max profit. Okay, now we are going to come to the sliding window thing. Okay, the sliding window thing, it requires us to subtract the profit. So for sliding window, we are currently here, right? So what we want to do is we want to move here. So we're going to subtract the 7 one. So what we want to do is current index is going to be plus plus. We're going to increment the index by 1. So we are going to move here. I'm going to subtract this one here. Oh my gosh, this is quite the what do I do? So okay, before we do this, we are gonna do a for the next phase, right? For the next phase, we want to do a max profit. Sorry, profit minus the previous one, which is going to be the bought price. Profit's gonna be minus current profit. We can have another value in here. Current profit is equals to 0, and then we can have in bought price current profit over here, and this is going to be current profit. Okay, so once we are here, current profit is equals to, we want to get rid of the current profit minus our bought price. Okay, so this one is going to be, let's say our this value is like minus 6, right? It's going to be minus 6 minus 7, which is going to be, oh my gosh, what the fuck, 7, 8, 9, 10, 11. I think I might have to check out the solution. This one is a bit tricky. So the bought price is going to be this one, and then we want to add the new one. So we were here, we checked this one out, we subtracted this value, and then we have a 1, right? So we want to add plus 5, yeah. So current equals to current index plus 2. So when I do this, so we are at 0, right, initially, and we are, this is our sold, this is our price, then we have a max profit of minus 6. Okay, so we have minus 6, right? So what we're doing is we are subtracting this minus 7 from here. So it's gonna be 13. And then so what's gonna happen? It's gonna be minus 13, and we have 1. Then we are adding plus 5. 0, 1, 2. Okay. To now we have to work on. Okay. Brain's kind of lagging right now. I'm not gonna lie. Okay. this loop is never going to end. Okay. So when are we going to reach the ending condition? That's what I'm curious about. When x plus 1 it's less than rices dot length. And this is what we are gonna do. We're gonna return max profit. I think that's it. Okay, but this doesn't do anything. We are not making use of the current profit anymore. We're not making use of the current profit anymore. This one's like new, right? This pattern is new, so it's plus I haven't like looked at a code snippet either. I'm trying to do it everything from from memory, not memory, but like the visual understanding. So translating the visual understanding to code can be a bit tricky. So we can't use a for loop because there is no fixed number. But what we can do is this is like kinda a bit like dynamic programming because we store the value, right? We store the existing sum that we calculated. So current profit can let's just keep it at 0. So current profit. So we are starting off with 7 and 1, right? So find the sold at sold. Sorry, let's just say bought. Bought is gonna be 7. No, we have to work with current profit. Current fucking profit. So if current profit, we'll just have a boolean, I guess. Calculated once is gonna be false. If calculated once, if we haven't calculated even once, right? Then what we are gonna do is current profit is going to be rices to the power. Let's just call this I bought sold, right? Sold plus 1 minus prices to the I. Okay. Okay. So if we have it calculated once, then we are gonna calculate is equals to true profit 1. Then we're gonna check. Else, if we have calculated previously, right? If we have calculated previously I plus plus, we also have to do I plus plus. Don't forget that. Or maybe we'll do that later on. What we can do is we are here, and then I plus plus happens at the very bottom. So let's say I plus plus happens here. Okay, if I plus plus happens there, what do? We have the previous sum. So like if we haven't done any calculation, then we are doing it here, right here. Then we are simply going to do some checks. Okay, so let's skip else for now. We're going to increment the value of I by 1, and we're going to do an if current profit is greater than max profit, then we're gonna set max profit to current profit. Okay, as simple as that. And oh yeah, the good thing about this one, what do you call that, C#, this is what I like. Max profit is equals to current profit greater max profit. Is this condition true? If this condition is true, then we are gonna set the current profit as the new max profit, or else we're gonna keep it as it is. This is exactly the same what do you call that, that if else statement, right? We just wrote an if, right? It's exactly this one, but written in one line. This is nice if you want to, you know, make things short. Okay, so we're incrementing I by 1. Okay, that's the case. What are we gonna do? Okay, so we're updating the max profit, and now this condition is also true. And yeah, the second time, yeah, now we are gonna loop, right? This time we're gonna come in the else section because this is gonna be true now. So now we have a current profit value to work with, and our index is gonna be here at 1. So what we can do is, you know what? Let's not do this. Let's not do this. So yeah, let's not increment the value of I. So it's still gonna be here. What is going to happen is the new calculated current profit, right? Current profit is there. So current profit, we're gonna do a minus now. Is equal to current profit minus the previous value, which is going to be the 7, right? The 7 is going to be the previous value, so it's going to be I. So prices at I, right? And then we also have to increment this one over here. So it's going to be current profit is equal to current profit plus, we are still at this level, right? So we to get, okay, you know what, let's do an I plus plus. We'll do it I minus 1 plus prices, and then we can do I plus 1. So I don't know if this is easy to understand, but when we are looping for the first time, this condition is going to be false, right? So we are doing this thing. We're setting this to true, and then we're setting the value of current profit to something, I don't know. Well, for yeah, 7, we're doing 1 minus 7, which is going to be minus 6. Okay, minus 6 is what we're going to be doing. And then the second time we loop, this is going to be what do you call it, true now. So we're going to be here. Okay, so when we are here, we're updating the current profit to current profit minus I minus 1, which is going to be our current profit. Let's say this was minus 6, right? So this is going to be minus 6 minus 7, so it's going to be minus 13. And then we are doing a plus I plus 1, which is like this value over here. So minus 13 plus 5. So here it's going to be 1 minus 7 is equals to 6. And then when we reach here, this one is going to be the current profit is what is it? It's supposed to be minus, okay. And the current profit is minus 6 minus 7 is equals to minus 13. And here the condition is going to be minus 13 plus 5 is going to be, what is it, 13, 12, 11, 10, 9, 8, minus 8. So something like this. I don't even know, man. This logic doesn't seem correct. This logic doesn't look correct. And the condition's like fucked up as well. But at this point, you know what, I'll give it one shot. And if it doesn't work, I'm just gonna like check out the solutions. Okay. Okay, case 2 somehow worked. Okay, yeah, because the output is 0. Okay, you know what? 715367, right? 7165. And you know what we're gonna do? Because so what is the value supposed to be? It's supposed to be 5, right? So it's supposed to be 5 because 7, this is a loop, Okay. The reason, okay, let's understand the question first. Yes, 7 1 is not possible. No. Okay, this is not possible. Okay, so we are doing a 1 minus 5 kind of thing. I see. It's 0. I see. What if we do? Okay, what if we do 7? We bought at 7. Then we sold it at plus y. So plus 1. This is not gonna work, but I'm just doing it because why not, man? Both of these cases are wrong. Put on expected 0. So if we do it this way, it's gonna be, what do you call it? 7. Yeah, so this is not the way to go. That's 1. And okay, this condition is, I think this is true. This is correct. Let's just debug this. Debugging is, I think, the best way to go about it. So we have this function, right? So let's public void max test. Let's just call it test, and then we'll just call max profit. This is our variable. Fuck, dude. Okay. What the fuck, man? Okay. So we're gonna be we're gonna add a debugger right here. We're gonna check step by step what's happening. The answer is supposed to be 5, but we'll see if it's 5. So let's go to program and let's create our, what is this thing called? I think it was best time to buy sell. Stock is equals to new. Okay, and then we're gonna stock dot test. We're gonna run this function. So let's add a debugger. We already have a debugger, so okay. What's wrong with you, man? Okay, oh, it was running. Come on, fam. Don't keep me waiting. Come on, fam. Don't keep me waiting. Don't keep me waiting. Come on, fam. Okay, so yeah, let's go. So we are inside the max profit function now, and the prices is going to be our map, like 715364. This is what we're doing. So I is going to be 0, max profit, everything is going to be 0. So this value, right, I plus 1. Yeah. So okay, we are calculator. So we haven't calculated once, so we are calculating the current profit. So current profit is going to be -6. That it makes sense. Then we are incrementing the value of I by 1, so it's going to be 1 now. Okay, then the max profit is going to be 0. Yeah, because this is not the right way to sell stuff. So the second time we repeat, this is gonna check this one out. So I -1. Okay, so currently we are at 1, right? So this one right here. And what we are going to do is
No one kêu hỏi
sao vậy?
bên
Sao
đây
lại
đi
này? Wow, sao lại này?
dịp này baby
Wow. Sao lại là này? Okay.
tao mày đi bạn
Yeah, bye.
ala sala no wish ta khaika
Kaya,
khai tam phu
nanatay ko happy eat. Nagsasasa no? Say me wish the khay nang bam phone ba bisa wish the khay masa nang wish khay sa to da này.
wish khai le za da da ta na te hin ke
Không biết cái masa. Chả quan cốt khi nào bảy đuôn không
khai
sorry.
cái đi ini call khai tak da no ko sa ne ya su Eid Mubarak shimi sa te
Đã có.
da ham da ta college ni cho ni tum ka shi te pa ni
Đã có.
này
Đã có. Đã có thân đi đâu? Thân đi.
อย่าจะตกหาไส้ตกแล้วทำไม่ทันตกก็
Okay, so current profit is minus 6, right? And current profit minus this price at what is this? I is
อันนี้เราทันได้
0. Tawi ako. Nan ba ko sa lang tawang kasi kahit ng counter. It's gonna be at 0. I is 1, right? So 0. So 7. So this is gonna be current price minus 7. And then current profit is gonna be current profit. So we are getting rid of the previous value, which is going to be the other one. It's gonna be minus 13. This one is and then we're adding plus 5, so it's gonna be minus 8 or something like that. And then we're incrementing it by 1, and we're checking if the profit is valid. This is not valid, so we are going again, and this time the current profit is gonna be minus 9 and minus 6. Okay, and you're going again, maybe minus 11 and minus 5, and then minus 8, minus 4. So it's like always in the minus. I think the problem is something like this. It's a bit hard to understand when to do the minus and when to do the plus. So let's try it out again. Okay. Okay. Profit is gonna be 1 minus 4. Okay. It's gonna be minus 3, minus 6, minus 1, minus 7. Okay. Minus 4, minus 8. Nah, it doesn't work. This is not the issue. I think we'll have to look at the answer. Eid Mubarak. Relax. Eid Mubarak. Yeah. So I kind of get the idea, but I don't really know how to implement it. To publish, submitted this one AC to publish a solution. What is this? What does AC mean?
In this video, we'll go over LeetCode question number 121, the best time to buy and sell stock. We are given an array of prices where the ith element of the array is the price of a given stock on the ith day. Given this array, we have to return the largest profit that can be made by buying the stock on a certain day and selling it sometime in the future. For example, let's say this is the array of prices. So on the first day, the price was 3, on the second day it was 8, and so forth. In this example, the highest profit would be 6, which can be made by buying the stock at 1 and selling it at 7. Note that buying at 1 and selling at 8 is not possible here, because 8 comes before 1. Now, the brute force way of doing this would be to calculate every possible combination of buying and selling prices. So starting with the first day, where we can buy at 3, we calculate the profit of selling at 8, which comes out to 5. If we sold on the second day at 1, our profit would be -2, so it would be a loss, and we'd continue this and calculate the profit for each day in the future. Once we're done with that, we'll calculate all the profits from buying on the second day at 8. Notice that we can skip the first block because we can't sell at 3 since that's in the past, and we also won't buy and sell on the same day, so we can start on the third block and calculate the profit for selling at 1, which is -7. We'll do this for the entire row and calculate the profit for each day. Then we'll move on to the third day, and using the same logic, we can calculate the profits starting on the fourth day. We'll keep doing this until we get to the last day that we can buy, which is on the 5th day. Now that we've calculated all the possibilities, we can now see that the highest profit comes from buying at 1 and selling for 7 for a profit of 6. Now, this approach works, but the problem is that this algorithm runs in O of n squared time. If you're not sure why this is O of n squared, skip to the end of the video and I'll explain why that is. But there is a way to do this in O of n time, and the key is to eliminate all unnecessary computations. But how do we know which ones are necessary? Well, let's visualize this information using a graph, where the day is on the x-axis and the price, let's say it's in dollars, is on the y-axis. The first step is to calculate the profit from buying on the first day and selling on the second day,
Nice,
which is
Indian Navy.
$5. However, the
Good shit,
fact that
man.
the price on the second day was higher than the price on the first day
Navy is
gives us a very
good.
important insight. If the
You
price was
you
higher
get
on
to
the
be
second
wet
day,
all the time.
then there's no point in calculating the profit where we buy on the second day, because we
It's just
buy
that
on the
you
first
you are
day
gonna
instead
turn out
for a
gay
lower
by the
price.
time you come
For
back.
example, if if we sold on the third day, buying at $8 gives us a profit of -7. But buying on the
Look,
first
I know
day,
this, I know this. Just show me the.
so you can compare the profit
Okay.
and loss. If you sell on the fourth day, buying at $8 gives a profit of -4, but buying at $3 gives us a profit. So the profit leads to sellers. In the fourth step, we keep row on our table end time prices as before, and the first thing we'll do is set the profit to 0, since the problem also says that if no profit is possible, then just return 0. Then we'll create a variable called buy, which will represent the buying price, and set it to the first element in the list, so 3. We'll then create another variable called sell, which will be our selling price, and use it to iterate through the list, starting with the second element. Here we'll take care of 2 cases. If the selling price is higher than the buying price, we'll calculate the profit and compare it to our profit variable and take the maximum. In other words, the profit variable will always keep track of our maximum profit. If the selling price is lower than the buying price, then all we need to do is update the buying price to be the new selling price, since we have found a lower price to buy at. So starting with the first iteration, sell is 8, so sell minus buy equals 5. 5 is greater than 0, so we'll update profit to be 5. Next, we'll look at a
What approach is this? This doesn't look like it's
less than the buying price, so we'll update the buying price by setting buy equal to sell. So now buy is 1. Next, the selling price will be equal to sell, less than the buying price. So we'll update the buying price by setting buy equal to sell. So now buy is 1. Next, the selling price will be 4, and sell minus buy equals 3. 3 is not greater than 5, so profit stays the same, and we move on. Next, the selling price is 7, and now sell minus buy equals 6, which is greater than 5, so we'll update profit to be 6. Lastly, the selling price is 5, sell minus buy equals 4, so profit stays at 6. And that's it. We don't need to do any more comparisons, and the profit variable now contains our maximum profit, so we can just return profit, and we're done.
See this solution. I mean, we can do this, but this is not what do you call that? This is not doing the sliding window thing. This is a bit different. But like, you know what? Let's try this approach first, so that we kind of have something to show. Code dicta. This is this one, Python, but I don't think this doesn't look like it's sliding window though. Okay, so the way we're gonna do it is what the fuck? Why is the code? I don't want to look at the code right now. So we are gonna have a price int buy. So it's gonna be prices. So we are assuming that we start at 0. Okay. Okay. We're gonna start at 0. And then we're gonna loop for var v in cell, right? Okay, we have to start off for int I is equals to the 1, I is less than prices dot length I plus plus. Okay, so we're gonna start at 1. The reason is because we are already at 0. If prices dot length is equals to 1, we're gonna return 0, just to be safe. If there's only one element, then we're gonna return false. Okay, so what we want to do is int sell. Sell is going to be our this current prices to the power I. Okay, sell is going to be this current price, and then we also need to keep track of maximum. Int profit is going to be 0. Okay, sell. So we're gonna do int local profit. I'll call it local profit. It's gonna be or maybe say pos. Yeah, we'll call it local profit. It's gonna be our buy. We bought it at this much, right? We sold it at this one. Sell minus buy. It's gonna be our local profit. If local profit grew, okay, you know what? We'll set it this way. The always profit is equal to local profit greater profit, then we are gonna set profit, or else we're set it profit. Okay, so we are updating our profit value if needed. Okay, Oh yeah, no, we are supposed to do if sell is greater than buy. Okay. If our sell is greater than buy, then we are gonna calculate the profit. Okay. And then we're gonna do this. If our if the selling price is higher than the, but if it's not, then we are gonna sell buy is equals to sell. I think this might not work. Oh wait, we haven't even returned anything. So we are gonna return profit. It works right here, but I don't know if it's gonna work when we submit. It's accepted, but I don't think I'm not satisfied with this. I think there has to be a better solution. Okay, so our buy, right? So buy price is, let's say we are starting off at, where is that? 7. So if, and then we're selling it at 1. Okay, so if it's greater, then we are checking if we made some profit. Okay, it's a profit, then okay, that is. But if not, if we are not in there, then if this is not the case, then we're gonna, the new buy price is gonna be this one. Okay, so we are buying whenever we encounter a low number. So whenever we encounter a number lower than the current buy, we are buying that one. Okay, I get the idea. So whenever, and then if we encounter a number whose value is more than the buying price, we sell it and calculate the profit. If the profit is greater than the maximum profit, then we update the maximum profit as well. Okay, this one kind of works. I'll just copy and paste this in my program. Right, this one. And this is going to be the first solution. And I'm going to keep track of the I'm gonna just write the description. So what are we doing? Note down the buy price. So set the first value as the buy price. That's the buy. Iterate from second element, and if the, and set the current element, iterating element as the sell price. If sell price is less than buy price, then that means we should be buying this element, hence set this as the new buy price. If sell price is higher, that means we can sell it and get some profit. So calculate profit and update the max profit if needed. It's greater if current local profit is greater. Local is called profit. And then we're just gonna repeat this. Yeah, this is kinda, yeah, this one's much more simpler to understand, but this is not sliding window. I think we can do better. Content. Yeah. This is I think we'll check the other solutions. Okay, all solutions. But it's like O of n. Best explanation ever possible. Damn. I wonder All this other employed is approach to trace through the area of stock price. Stock price so far. I mean, this is exactly the same one. It's just keeping track of the price and then iterating and then just doing what he needs to do. What? I thought like people are gonna use sliding windows. What the fuck? Is this the best one? Exactly the same. In price. Buy, sell. What the fuck is this code? Which is this Python? It looks so bad. I can't even figure out what's happening. Max profit is set to 0, and then buy sell is set to 0 and 1. Okay, then the max profit is max profit, comma, and then we're selling or sell and buy. Okay, if price is greater than price to sell is greater than buy is equal to sell. It's the same exact thing, but a lot more ugly to look at. Not easy to understand. Shit code. That's not how a person should be coding. Okay, I guess there is no better solution. Best approach, brute force, better solutions, O of n. Okay, optimal O and n, O of 1.
हेलो गाइस, वेलकम टू माय यूट्यूब चैनल। और बेसिक क्लियर नहीं होगा, ठीक है। इस केस में टीएलई ये हमारा माइनस मैक्सिमम हर इंडेक्स से जो सबएरे बन रहा है उसके सम को हम कैलकुलेट करते जा रहे हैं और उसको मैक्स के साथ कंपेयर कर करके अपडेट करते जा रहे हैं मैक्स को। यही काम कर रहे हैं हम, यही काम कर रहे हैं, ठीक है। अब यहाँ पे भी हम यही काम करेंगे, यहाँ पे भी हम यही काम करेंगे। ऑर्डर ऑफ एन स्क्वायर का सॉल्यूशन बनता जा रहा है, ठीक है। अब करंट सॉल्यूशन
What's it doing? Okay, let's see. Price dot length. Okay. And then max profit, current max profit is 0. Current max profit minus 1. Okay, we're starting at I see, we're starting at 1. So 1 minus, okay, and then the current profit. And 0, then we don't do it, anything else. We're setting the current profit. Profit is greater than 0. It's the same shit, man. But I think this one is it doesn't use just calculating, pretty much the same. If you want to do it something similar to this, I think this one is gonna be something like, what do you call that? Let's just call it profit. 0 for I is equals to 1, because we wanna do a -1. I is less than prices dot length I plus plus, and then that's it. So what you want to do is current, you can do an int current profit is gonna be let's say prices and I minus prices I minus 1. So if our index is, let's say, 715, right? So we are gonna do 1 minus 1, which is gonna be this one. 1 minus 7, that's what's happening right here. Okay, so if current, okay, we're gonna update the profit. Profit is equal to you could say current profit greater than profit. Then if this is the case, then we're gonna set current profit else profit. Okay, Never mind. Okay, let's see what's happening. We are iterating 7 minus 1, 1 minus 7, and then this is not greater than this. Okay, the second time gonna be here. No, sorry, it's gonna be here. Then we're gonna do a 5 minus 1. And then we're gonna notice that it's something like 5 minus 1 is gonna be 4. Set the bracket to 4. And then we're gonna do a 3 minus 5 and then 6 minus 3. Ah, okay. Okay. So we cannot be iterating this way. Okay. I see. So yeah, this is not gonna work. We have to do something. Oh, it's pretty much the same, dude. If we do a minus, but instead of doing this I, we just have to keep track of what do you call that? Yeah, it's the same shit. This one's a bit more confusing to look at. I thought this is different, but nope, this is not different. It just has a current by, something like by. Or we can say by index, something like that. And then we can have here else if we can do price by index is equals to I. This should not work, but I'm just doing it. Yeah, this is gonna be if oh yeah, this one is going to be this is gonna be I. It's gonna be by index. Okay, so this one's gonna be if prices I is less than same shit, dude. It's basically the same shit. We're doing a bunch of if checks. I don't think it's gonna be any different. I mean, it says that like the runtime is different, but it doesn't really matter. 5%, and this one's 12%. It doesn't really beat anything else. I wanna know what this fucker's 0.6 resolution use 310. Okay. Oh, so like. Okay, so like it's the general range. This is this fucker just got lucky. You see this, right? This is his code, okay? And he's just doing the same thing, I assume. Let's see what he does. So he's looping from 1. Current price is gonna be 1. And then he's checking if the current and yeah, pretty much the same. He just got lucky with the what do you call that? The speed. Nothing else. Yeah. Fuck, I thought we were gonna use sliding windows, dude. I guess not. Like I was trying to figure out, how we can use sliding windows in this problem, but it didn't really make any sense because we are dealing with two numbers in here. Just like here they're dealing with like 1, 2, 3, 4, 5 numbers, right? So it makes sense to use sliding window. You can get rid of one and then add another one on the right side, and it's gonna update the new sum. But in my case, in this profit and loss, we are dealing with 2 numbers. That's it. And I was like wondering what, like it's going to be more expensive to remove items and add items. So this didn't really make sense to me. But we solved another issue, so that is good. And I think I'm going to copy this. What do you call it? Where's my code? This is mine, right? I'm gonna copy this and add it as solution number 2. Max profit 2, and yes, this one is also done. I think I'll see if I want to do another one. We're done with these. Can I tick them? It would have been nice. So binary search is there. Reversed linked list is there. This one is probably fun as well. Okay, we have linked list circle. We have inverted binary tree and all those things. Okay. Fucking hell, the number of codes the thing has, it's crazy. I need to start keeping track of codes. Okay. Group anagrams is there. Valid palindrome, hard. I'm gonna finish off the easy ones first. Valid parenthesis is done. Min stack is not done yet. Binary search. Yeah, let's do binary search. Given an array which is sorted in ascending order and a target which write a function to search target. If target exists, then return index or return number 1. Okay, so you know binary search, right? If you don't, I'm gonna show you. I think it's best if you have a clear idea of binary search. Binary search is really nice to look at as well, but not as nice as this. Fuck.
ทุกคนครับทำใจสบายๆนะครับผมเป็นหมัน
สบายอยู่แล้วคณะใส่ซาบีนาบาเลสที่มี
Good ad. Binary search. I want to show you a visual representation. Visual. Oh yeah, yeah, this is good, animated.
What makes binary search so important? 50. If I that question, let's first take a look at this array of numbers, ranging from 4 to 50. If I asked you to tell me what index the number 27 is at, you could probably figure this out pretty easily by just, well, looking at it. But what if you could only look at one number in the array at a single time? How would you figure out the index then? Well, in that case, the simplest approach would be to start at the beginning and check each number until we found or didn't find 27.
This is the linear way
Count of the numbers we had looked through.
of searching.
This approach, or algorithm, is called linear search, which is a rather fitting name, as the algorithm works by searching an array in a linear or sequential fashion until it finds or doesn't find the result it's looking for. In the worst case, this means we need to search the entire array, such as if we were trying to find the number 50. As this array only contains 9 numbers, the linear search algorithm is not only fine, but actually encouraged, due to the way that CPUs optimize. However, for arrays that contain thousands or even millions of numbers, then linear search can be incredibly slow. However, in this case, because our array is sorted, we actually have another option available. Let's see this option in action with some new numbers in our array. Again, we want to find the index containing the number 27, if it exists. However, this time, rather than performing the linear scan starting at the beginning of the array, let's instead start at the middle and check the number there. This time, it's not 27, instead it's only 14. However, we can actually make use of this knowledge. Because we know the array is in a sorted order, then we know that the number 27 isn't going to be in the first half of the array, so we can just discard it. Great. By doing this, we've managed to reduce the number of indexes we need to take a look at by half. Now we can start our scan. But wait, rather than scanning through all of these elements, what if we just do the same thing again? Let's go ahead and jump to the middle. Turns out our middle is in between two indexes. Well, that's okay. Let's take a look at the element on the left-hand side of the middle instead. The value at this index is 30, which means that 27 can only be to the left. So there's no point checking the two higher indexes. All that remains is our final index, which, in case you lost count, is index number 5. Let's go ahead and check it. And there it is, number 27.
Binary search, baby. This is it. This is binary search. Fancy, right? It's like pretty interesting. Binary search is interesting to work with. Okay, so we're gonna start with our binary search. We're gonna get the middle. We're gonna check the middle element, and then we're gonna split it. We're gonna get rid of the what do you call it? Index that we don't need anymore. Okay. Okay. So we're gonna have a pointer starting and the ending index. So we can have int starting index, which is gonna be at 0, ending index, which is going to be at what do you call it? Nums dot length -1. Okay, makes sense, right? And then we can also have our ending and starting, ending, and current index, which is, let's say, going to be at nums dot length -1 divided by 2. So you know we are gonna be in the center. So if we are 7, we are gonna be at 6. Okay, if that is the case, then we're gonna be 1 2 3 4 5 6 5. 5 divided by, what do you call that? 5 divided by 2, it's gonna be 2. 2 0 1 2. So somewhere around here. I think this is the one. Yeah, somewhere around here. And for this case, the fuck, where's case number 2? Okay, let's take this as an example. Oh, it's just okay. It's 9. Okay. We can do in length. I'll just stick to length. It will not make it complicated. Okay. This one is okay. So we're gonna start index number 2. So let's not loop for now because I don't know. I kind of forgot how to do things. I'll try to figure it out as I go on. The current index is gonna be here, right? So int element. Then now we wanna check the number. The current val is gonna be nums, our array, and the current index, which is gonna be at the center, right? So we're gonna return if current val is equals to target. Then we are simply going to return the current index, which is gonna be current index, right? But if it's not the case, we are gonna check if the left side is greater or the right side is greater. Alrighty. So if current val is less than what do you call it? If current val is less than the target, then what we want to do, and then else if current val is greater than target, we're going to do this. Okay, so if the current val is less than the target, which so we are here and the target is greater, so we can get rid of the left side, right? For example, let us in our case, let's say the target is 12. Let's say we are in here, right, in center. Let's like 3, we are in 3 and it is less than 12, so we can get rid of the left side. Yeah, so our left is going to be our starting index. Starting index is going to be our current index plus 1, because we already checked this one, so it's not going to be this, so we can put it at here. Okay, you got it right. But if that's not the case, we want to update the ending index is equals to current index, which is going to be, so let's say our target is 0, right? So we want to update the ending index to be -1. Okay, -1. Yeah, so this is basically what we're going to be doing, and yeah, that's it, kinda. So oh yeah, no, we also have to update the current index, the ending index and starting index, right? 0 plus 9, and then we can update the length. Yeah, the current index, it's gonna change. So the second time we repeat, we are going to have to update the current index again. The current index is this time going to be based on this range, right? So we can do a starting minus. Okay, yeah, we can do a starting index minus ending index. So at the very start, this is just basically going to be 0 minus. Okay, we have to do it the other way. Ending index minus starting index. So this is going to be 9 minus 0 at the very start, so which is basically 9. And then as we keep on shrinking, let's say we got rid of 9, 4, so it's going to look like that. Yeah, so we are basically shrinking. Okay, shrinking the array and then doing what we need to do. Okay, so this is going to be inside the while loop, and while ending index is greater than starting index. Okay, as long as this condition is true, we are going to be repeating this. Okay, so let's put it here, and all of this needs to be here. So let's run this. Oh, we haven't returned anything. Okay, and this needs to be double equal to, and then if this is not the case, then we will return -1 if we don't find anything. I think we are stuck in an infinite loop. Yeah, we are stuck in an infinite loop. Okay. Okay, so ending index is greater than starting index, right? So at the very start, this condition is going to be true. When we calculate the current index, it's going to be, or let's just say mid index. Let's just call it mid. So mid index. So we have the mid, which is going to be in the center somewhere right here, and then current value. We check the value of the mid, and check. Yeah. In the mid, then we check if our target is correct. Let's put it here to make it a bit more easier to understand. So we're checking if this is the target that we're looking for. If it is not, well, then we're gonna check if the target. So our target is 12, right? So if it is lesser than 12, yes, it is lesser than 12, which means that we need to get rid of the starting index. We have to move the starting index to 5. It's gonna be 5 mid plus 1, which is gonna be 5 right now. The ending, it's just going to be as it is, 9. So now our 9 minus, let's say 0, 1, 2, 3. 9 minus 3 is going to be 9, 8, 7, 6. 6 divided by 2 is going to be 3. I see. Oh, yeah. So on the mid, right? The mid has to be a bit different. Mid is not going to be this. This one is going to be starting index plus med, yeah, plus med. Oh yeah, med. This one's gonna be here. Okay, it kind of worked. Got a target 2 minus. Okay, it just works when it's -1. When the target is not something else, it doesn't work. Okay, so let's do a dry run again. Mid is going to be our ending index. Actually, no. Mid index, alright, mid index. Let's just calculate the mid index directly. This is going to give us the, and then what we want to do is, this is going to give us the center point, and we want to offset this by starting index. So what this means is, let's say our starting index is at 5, right? 5, and then our ending index is 9. Okay, so what we are doing is we are doing in 9 minus 5, which is gonna be let's say 9 minus 5, which is gonna be 98765 it's gonna be 4, right? So we have 4, so our mid index is going to be 4 plus 5, which is gonna be, I said, what the fuck, no, this is wrong, this is not starting index. Oh, we haven't divided it by 2, what the fuck, we're supposed to divide it by 2. Divided by 2, yeah, so it's gonna be 2, right? So our starting is 5 plus, so our starting is 5, and then we end up at 2, so it's gonna be 5, 6, 7, so it's gonna be at 7, so 7 is going to be our mid index. So if we do this, mid index, okay. It's not gonna change anything, or maybe it does. What the fuck? Oh, why did this change anything? Doesn't make any sense. Like, this was basically what I did earlier. Index based on calculate based index based on starting and ending position. Okay, and then we're checking which one is valid, which one is not valid, and then okay. But I think it's not gonna submit. There should be some cases where it's not gonna work. Okay, yeah, for example, like this, when the length is like, 1, if ending index is greater than target is 5. I see. What if we make it is equal to, what if we make it this way? This one is gonna work, but what about submitting it? It works. And it's like not much different from the top speed. Mine is like where's me, 200, right? Minus 200, and this one's like, let's check out their code, and it's gonna be length minus 1. It's basically the same, exactly as I'm doing it. It's just splitting. This fucker just got lucky with the timing. That's it. Okay, gonna copy this. It's gonna be the binary search. I'm gonna create a binary search solve. I'm gonna paste it. I'm not even gonna bother making the readme because it's quite obvious what it's doing. Binary search is binary search. Okay, it's 8:30, right? For how long? Okay, I've been coding for 2 hours, 30 minutes. Okay, I think we can do one more and then we can stop. It's been quite some time. Did we submit though? I think we did, right? Yeah, we did. Good. I wanna check how many did I submit yet. 13. Dude, it's just 13, dude. I thought it's gonna be more. We just solved 3 problems today. Are you shitting me? I thought we solved more than what do you call that? Oh, more than yeah, more than 13. I thought we solved more than 3 today. Anyways, we solved a binary search. Now this one's linked list. Then we have inverted binary tree. Okay, we're supposed to invert a binary tree. Maximum depth. Oh, this one's gonna require us to use those DFS, BFS algorithms. Let's do this first by reverse linked list. merge to sorted linked list. Oh yeah, I did this earlier, but you know what the problem is? I remember doing all of this, but they don't exist in my record for some weird reason. Yeah, like I remember doing this, man. See, I even did this. I even have a comment. Did I never submit this? Maybe that is it. Oh wait, this is LeetCode. Never mind. Do Suba 1. Suba 1, what the fuck, man? Okay, reverse linked list. Which one should we go for? Reverse linked list. It's basically you are going to have a linked list and you are going to reverse it. And merge to sorted list is just going to be you merging to a linked list. Sorry, two list. You are going to be merging two lists. That's it. Which one do you want to do first? That's going to be the last one. Your server's not working or what? Nah. Okay. Okay, you see this, right? See, I did something, dude. I remember I did something. You see, I did this, man. I did this. It's 100%. Fuck competition. This one is in what? Java or what? Yeah, this is Java. This one? This is also in Java. This one in Java, yeah. I did this, dude. I remember. But it's been a while, so I kind of forgot how I did things. But the general idea is we are going to have... Okay, this is like an example, I think. Okay, so the way we're going to do this is we are going to start with a pointer. Okay, we're going to start with a pointer. We're going to add this and that and these and that and these and that and these and that and this and that. Okay, so let's say we are here, right? We are at 1. Our pointer is at 1. So we check the next element for both of the, both of the elements. Okay, and whichever is smaller, we set it as the next one. So right in our case, 2 is smaller. Oh, sorry, no, 1 is there. 1 is there, dude. I remember. Okay, 1 is there. Yes, so it has 1, 1, 2, 3, 4. Okay. So to accomplish this, okay. So let's say we start at 1, and then we check our next element and the current element. We check the current element. Okay. This, then this, and then this. I see. We also have to return the head of the merged list. Okay, I see. What are we supposed to do? What about likha hai site mein Java do in CS? Yeah, it's already written, but I don't wanna look at it. I feel like I'm cheating if I do that. So I'm trying to figure out the solution again. But I think I did this last year, so it's been super long. So we can start off with any list, and we want to check the next node and the current node. We are gonna check the current node. Okay, so we can have a pointer to both of the starting nodes, and then we are gonna move to the next node. Oh, sorry, we are gonna have a pointer to the first node, and then which one is smaller, we're gonna consider that to be the starting node. So in our case, both of them are the same, so we're just gonna take this as a starting node, and then okay, and then what we're gonna do is we're gonna check the elements: current second element, current first element. Okay. Current second element, current first element. Okay, so what we can do is current okay, list 1, right? List 1 dot val. Okay, val. Current node, list node. There, I think we need a new what do you call that? New array, new list. List node merged is equals to new, and yeah, that's gonna be it. Okay. So this is gonna be our merged one, and this is where we're gonna be storing our updated values. Okay. That is good. This is our merged one, and yeah. The current var it is called this list node, and also we need to keep a reference to the head. It's going to be head, it's going to be merged. Okay, this is going to be like the head. Well, we are told to return the head, which means like the first element, so we have to keep track of it. List node current current one is equals to list one, and then we're gonna be non-current 2 is gonna be list 2. Okay. So what we can do is there is gonna be some kind of loop, but I'm not sure how do I loop, so I'm not gonna do first. I'm gonna try to do it without a loop. Make it bigger, can't see shit. So merge, right? If current 1 is how are we supposed to sort again? Smaller, right? Yeah, smaller than current 2. If that is the case, then we want to set merged dot val is equals to current 1 dot val. Okay. And now we need to take a look at the next one. Okay, then we want to update the next one. And if once we're done with this, current 1 is going to be current 1 dot next. Okay, so we are going to have the next one, and yeah, that's basically it. Else we're gonna do a merged dot val. It's gonna be current 2 dot val, and our current 2 is going to be the next node of current 2 next. Okay, so this is going to keep on going and going and going. Or current equal to null. Yeah, we also have to take a look at another case while. Okay, so this is kind of done, I think. But I wanna just yeah, we have to figure out a way to loop this. The condition is a bit confusing to me. While current 1 is not equal to null, and current or current 2 is not equal to null. So as long as it's not null, we're gonna keep on looping. So let's see what's happening. Let's do a dry run and see if it's and ultimately we want to return the head. Okay, so merged is going to be head. Oh, we also have to update the merged this one. Okay. And then yeah, we also have to update the merged one. Yeah, so going to create merged dot next is going to be new list node, and then oh no, we have to create a new var next node. It's going to be new node, and then merged dot next, right? It's going to be next node, and then we want to update merged is equals to node. So we are like proceeding to the next node. Okay, so what's happening is we're checking if they're both null. If dot val, oh, it's supposed to be val, this one is supposed to be val as well. And then current 2 is going to be in dot next. It's not equal to null. Okay, yeah, I kind of get the idea. Is greater than the or current 2 is equals to null. Okay, no, we have to, oh my gosh, I hate writing this kind of conditions. If current 1 is not equal to null, okay, if this is not null, then what do you want to do? If current 1 is not equal to null, then we want to check if current 2 is equals to null, or current 1 dot val is lesser than current 2 dot val, then we are gonna have this condition right here. I want to fix this up. Yeah, so we don't need this. Okay. Else if current 2 is not equal to null. Okay. Okay, what is the case? We want to do this. Current 2 is not equal to null, and we can do a similar thing if current 1 equal to null, or current 2 dot val is less than current 1 dot val. Then we're gonna do this. Okay, but this doesn't. It's just conditioning, just a bunch of conditioning. Not. I think the main thing is kind of done already. But I think it's gonna, not work for some of the test cases. Out of memory. I think we are not supposed to use a different. Okay. Out of memory. But it does work, I know that. At least to some extent. But we are not allowed to use we are not allowed to use a new, what do you call that, yeah, a new object. I guess we are supposed to somehow manipulate this without making use of a new object. If you use a new object, it's quite easy. We can just do this. But if this is not allowed, then we'll have to see. Okay, so we can iterate list1. Okay, let's see what we can do instead. Iterate list1 and keep on looping until this one is not null. Current 1, current 2, and this is going to be the head. So we can iterate this. So check if this one and this one is, which one is smaller. Which one is smaller? We're going to set it to the head. So by default, this can be null. Then that's going to be set as the head, right? And then once we're done with that, check the new one. Gonna get the idea. So we're gonna do is if current dot val, current 1 dot val is less than current 2 dot value. So if the current one has lesser value than this, then we can say updated. So what we can do is updated. Updated is equals to going to be current 1. Okay, it's going to be current 1. Then current 1 is going to be current 1 dot next, because we want to access the next one. We want to move on to the next one. And we also want to update our head. If head equals to null, then we want to set our head to updated. Okay. But if that's not the case, then what we want to do is updated is going to be current 2. Okay. Okay. And then current 2 is going to be current 2 dot next, and then if pretty much the same code. Okay, but updated, right? The next time we want to be a reference to something else. We want a reference updated. Fuck. Okay. Without so we have updated this one, but now we need to create the next value. If updated is equals to null,
If this, can you try this and tell me how is it, Kutum? Talk? Normal है ना? Normal मुझे है ना?
Masala dong. Okay. So we have updated. It's in the current one. And then we want to update the current one. It's gonna be current one dot next. Okay, kind of tricky. Very kotha. Oh yeah. I'm hungry now. So what we're doing is we have this updated value, right? So if it is null, which means that it has not been initialized yet, so we are also that head is equals to updated. Yeah. So we are setting it to current one. Okay. We're setting it a current one, and we're also been updating the head. But if there is a existing variable already, sorry, if updated was already set, then we're gonna set the updated dot next to the current one, and then we're gonna set the updated to the next node, which is basically current one, and ultimately we're setting the current one to the next node of current one. That is so confusing to say. Fucking hell. And the same goes for the else. We're just gonna copy this and paste it here, but instead of current one, we're making use of current two, and current two. Yeah. Okay. This is not gonna work, but just wanna do a while loop and do some printing to see what is happening. Okay. This is not gonna work. I just wanna see what happens when we print stuff. Oh fuck. Okay. My eyes are itching. So every time we update the this one, I want to see what's happening. So so let's do a console dot write line. Let's just print the value. This is gonna be, oh, we can just do this current one. Current one dot val, and then we're gonna move to the next one, right? Yeah, so this is it. And then or else we can actually just write it here. Now we need to write it here, yeah, before we update the current one. Same goes for here, current 2.val. Yeah, so it's gonna be stuck in an infinite loop, but I want to see the print statement to know if you're if the logic is correct. After that, we can fine tune the conditionals. Sabhi beja le bhai. some. So 1 1. Oh, it's okay, it's stuck at 2. 1 1, and then it's like stuck at 2. Oh yeah, this one is supposed to be 2. Fuck me. Run this again. Yeah, this one it was like destined to come. This is fine. I don't care about that. 1 1 2 3 4. Okay, yes. Hell yeah, hell yeah. You can see that it's sorted. You see this shit, right? Also, let's make it print in one single line so that it looks a bit more fancy. It's not bad, Jolly. It's a bit, you know, once you get the hang of it, it's yeah, 1 1. You see this, right? It's following the syntax. 1 1 2 3 4. So yeah, this is basically what we're doing. Okay, we are starting off with a null. This is where we're going to be storing our this one. What do you call that? Our updated linked list. So firstly, we check these two values. Okay, and then we check that if then both of them are same, so we choose any one, and then that's gonna be our updated what do you call that, updated value. So this is gonna be into 1, right? So let's say we choose this, right? And this is our node number 1, right? Let's call this, can I rename this? I cannot. So this is node 1, this whole list, right? The first one, the red one, this is going to be your current one. This is going to be your current to the second one. So we have this updated, this is going to be empty, and this is where we're going to be storing our lists, the updated lists. So we do, if the first element right now is going to be 1, right? And this one is also going to be 1. So current 1 has the value of 1, current 2 has the value of 1 as well. So our condition is, we check if 1 is less than this, what do you call that, 1. We check if the red one's value is less than this, which is going to be false by default. So and then we store this in the updated one. So we are going to store this one right here in our updated. Okay, so this is what it's going to look like. And then we use this, right? So we want to move our current 2 to the next node, which is going to be 3. So this is what we're doing right here. Yeah, here we're updating it. Okay, and now we check these two values. We haven't moved from current 1, so we notice that 1 is lesser than 3, right? So we update our updated linked list with this value, new value right here, and we used this value, right? So we want to move this to this right here. So now both of them are pointing to this respective nodes. And similarly, we check again, we see that 2 is lesser than 3, and so we store it in here, and then we move this stored value to here. So we are moving forward in the linked list. So now it's 4 and this is 3. This is what it looks like. And then we repeat again, and we notice that this time we are at 3. 3 is lesser than 4, right? So we move this to 4, and then 4, and then 4, blah blah blah. So I think you get like the basic idea, right? We're just like comparing, and whichever is lesser, we store it and we move to the next node. It's as simple as that. 1 1. So we can choose. We choose this one, and we store this. We move over here, and then we compare this. We see that this is lesser. We store this. We move over here. Then from 2 and 3, we notice that 2 is the lesser one. So we store this and move here. And then from here, from 4 and 3, we notice that 3 is lesser than 4, so we move, we store 3 and move 4 4, and then 4 4 it's basically the same, so we store these two at the end. Okay, so this one is working. We just have to fix some logic. Okay. If current 1 is not equal to null, okay. Not equal to null. If it's not equal to null, then we want to check if current 2 is equals to null, or current 1 the val is lesser than current 2 val. If any of this condition is true, then we want to do this. Okay, So we're just updating our conditions, that's it. Okay, but if it's not the case, then we want to do another else. This is such a pain in the fucking ass. I hate conditions like this. Okay, let's fix this as well. But if so else if current 2 is not equal to null, so whenever it's not null, that's when we are treating it this way. Just copy this, gonna copy this. It's pretty similar, so I don't really care. Current 1 is equal to null, or current 2 blah, then updated. Fucking hell, this is so confusing. You go down just like Holy Mary, Mariana cross. Okay, you know what? We're gonna do this. I mean, like the fundamental is already done. It's just a bunch of if-else statements now, and this is the most boring part. I absolutely hate working on if-else. So if our if current 1 is not null, then we are checking if current 1 value is greater or lesser than 2, or if this one is current 2 is null by default, then we update current 1 right here, and then we also update this one. Okay, and then we also have to make sure that we update our current updated dot next is going to be pointing. Oh no, we have to do something. If updated is equals to null, okay, if updated is equal to null, then we're going to set this to here. Okay, else updated dot next is going to be current 1, and then updated is going to be updated dot next. Okay, and then same goes for here. It's gonna be here. Okay, yeah, so this is one of the conditions. Here. Okay, and the updated the next is gonna be, we don't need this anymore. Dude, this is so confusing. Okay, so if this is the case, then yeah. Oh yeah, we also have to update it. Current 1 is equals to current 1 dot next. Okay, so this is it. Let's copy this condition and let's paste it in here. While loop. Okay, the loop seems correct. So this in current 2, current 1, current 2, current 1, updated current 2, updated is current 2, current 2, current 2. This one, it might crash, or maybe we're gonna be stuck in an infinite loop. Yeah, we're gonna be stuck in an infinite loop, but while current 1 is not equal to null, or current 2 is not equal to null. So if either one of them is not null, we're gonna keep on looping. Compile error, not all code return. Oh yeah, we're supposed to return as well. So at the end of the while loop, we're gonna return head. Okay, run this. Oh, it's taking forever. What the fuck? I'll tickle you internally, and I see nothing wrong with that. Mariana, Mariana, cry. Na 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 na. What if I just do a console.print, but instead of this, I print the updated? What if I do this? What if I do this? This launch should not work. I mean, I didn't make any change, I'm just printing stuff. Where's my print statements, bruh? I guess we have to put it right here. Updated one. Null. Okay, well, let's see what the logic is. If updated is null, then we are setting it to current one. Okay. I see. We don't even need to do this. Much better to just do this. Updated is equals to. This is much more easier. Yeah, we can do a console.log, console.write. Whew. Give me some print statements. Give me some print. Give me another chance. Okay, why is this not working? Current 1 is not equal to null. Of course it's not null. Then if current 2 is null or current 1's value is less than this, then we are setting this to here. That we're updating the value of current 1 as well. Okay. Else if, and then if is equal to null, and then if equal to null, this one is false, that mission is false. False is a good term. Oh, so we can just do a break. Okay, where the fuck is my print statement, dude? I don't see my print statement. Is it not printing at all? Are we not entering this loop at all? We should be entering this. That's what's confusing me. Yeah, std output is here. Okay, this if condition is not getting triggered at all. Oh, I see. Else. Oh my gosh, what the fuck? How many things do I have to copy paste? Fucking hell. Yeah, it's basically me copy pasting this. Fuck off, man. Not ideal. Ugh. So this problem is not hard, okay? It's just annoying to do. Like the logic is already done. I'm just working with the, what do you call that, if else stuff. Yeah. I don't want to work with these. I don't want to work with these. Such a pain in the ass. See. If this so current one is never going to be null, we know that for sure. And then if current 2 is null or current 2 is null. Okay, so if current 2 is not equal to null. So what this means is if current 1 is not equal to null, so current 1 is valid, right? And we check if current 2 is not equal to null, then what we want to do is update it. It's going to be here. So pretty much exactly what we are doing here. But instead of do, it's going to be current 2, updated 1, updated 2, updated 2. And we can copy this. Okay, let's just run this. I want to see if there's like some print statements. Yeah, 1 is showing up. Okay, so what we want to do is else in the else block, we want to do something similar to this. I'm going to do an else block. So with this, it's 1. It's going to be 1, 1, 1. Come on, come on, come on. Okay. Conditions, bro. Conditions. Why are you being such a bitch? Conditions, bro. Conditions, bro. Why are you being such a bitch? Okay, let's just fucking do every single conditional separately. Current 2 is equals to null. Then it means that this is gonna be there. Okay, this is like fixed. Okay. Else if no, it's correct, dude. I don't want to work with these. This is correct. So if this is no. Okay, else. Equals to null, so the nulls and current 2 is not equal to null. Okay, so both of these are not null. We're going to do a this kind of check, else it's going to be current 2, and then it's going to be updated current 2 and current 2. Okay. Yeah, so if it's not equal to null, but if what if one of them is null, one of them is not null? Oh my god. This is such a pain in the ass. Such a pain in the ass. So the second condition that we might have is the second condition we can have is if current 1 is not equal to null and current 2 is equals to null. In that case, it's pretty simple. We just have to copy this and paste it right here. Okay, right? It's because current 2 is null, so you obviously have to use current 1. There is no other choice. Okay. So we're gonna do this else if, then we can do another else if current 1 equals to null and current 2 is not equal to null. So if current 2 is null, then we know for fucking sure that it's gonna be this one. Okay. Because current 1 is already null and current 2 is the only valid one. But if both of them are null, which means that both of them are null, else we're gonna return a break. Okay. I don't know, logic wise this sounds normal, dude. Okay, what the fuck? 1 4 2 3 4 4. It's printing what needs to be printed. You see this shit? It's printing what needs to be printed, dude. Okay. Okay, why is this not working? Hmm. I mean, it's printing the correct thing. Okay, let's just have this tester. I'll just ask ChatGPT to create the. Nah, not yet. I need to test it out. I think it's bugging right here, somewhere around here, but I can't really test it out. So what's happening is we are deciding which node do we update. Let's just set this to null by default. So if both of the nodes are valid, then we check which value is greater and lesser. So if 1 is less, then we set the node to use to 1 and update current 1 to true. But if it's not, then we set 2, not to use to 2 and blah blah blah. Okay. And then this condition is true. Ultimately, it's going to reach here. Yeah, right here. And here we set the updated to the current node that we are at. So yeah, I think we can make this a lot more shorter. Yeah, so we set the head to updated if head is null. If head is null, we set it to updated, which means we have the head element as well. Head node, and then we print the value of this. And then we set updated to updated.next, right? Okay, you know what we're gonna do? If updated is, I think what we can do is if updated is equals to null, then we set updated is equals to node to use, else what we can do is updated dot next. Sorry, it's next, right? Is equals to node to use and updated is equals to be updated dot next. I think this one is enough to solve the issue that we have right now. Yeah. Also, that like based on the print statements, right? Where's my print statements? Like it's correct. You can see that the print statement is correct. 1 1 2 3 4 4 1 1 2 3 4 4. So the answer is correct. It's just that my like the final list that I am returning, it's not working for some reason. So I'm just trying to figure out why it's not working. Come on, dude. I think it's gonna get out of memory. Time limit exceeded. I see, yeah. Time limit exceeded. 1 2 2 2 2 2. It's just printing 1 2 continuously. Okay. Okay. So if updated current one, updated, it's gonna be updated next. We are not. Are we doing that right here? So we can get rid of this. Okay, I think that's all we had to do. We had to make sure that we are not dereferencing updated next. So the cases are working, but when we submit, we are gonna know if it's working or not. Let's see. Accepted. I mean, not bad, but I want to see the best solution. The best solution is 62 ms, so it's not even that different. I think these fuckers just got lucky again. Yeah, okay. Their solution is if list 1 is null, return list 2. If list 2 is null, return list 1. The val. Oh, I think they're using recursion. Yeah, they're using recursion. Recursion, I see. This is not bad. Recursion is pretty good, I would say. Yeah. So this is solution number 1. Oh, because my loop was never ending. My loop was like infinite. So that's why. This is solution number 1. I think the solution number 2 is going to be using recursion.
If you want to
okay, so the way they're doing is, let's have a look at their code, okay? So on the first turn, list 1 is not going to be null, list 2 is also not going to be null. Then what they do is they check which one are they going to return. List 1. If list 1 is less than, list 2, then they're going to call merge function, and they're going to, this one, the next is going to be list 2. Oh my gosh, this is so confusing. Recursions are like so small, but at the same time, so confusing. Look at this, man. How the fuck am I supposed to figure out what's happening? Like it's gonna go inside, go inside, go inside. It's like nested function calls. This is what do you call that? So confusing to look at. Okay, 333. Yeah, so we have been coding for 333. 3 hours, 33 minutes. Nice number. Just like at morning. So we coded for 6 hours, 3 hours of brainstorming our project, and 3 hours of LeetCode. I think that's a good balance. I'm not gonna lie. I just want to see what's happening. So if this is less, then we set and the next to this one. Sort list, okay, and then send it. Oh my gosh, nah, man, fuck off. I'm not learning recursion. Fuck off. Recursion can suck my cock. I'm not doing that. I think I still have just 13 done. Yeah, because this merged one we did it earlier, so it didn't get considered. Anyways, pretty much done. I think we can stop for the day. Too many codes for the day. Too many codes for the day. Yeah. So let's see how many 1 2 3 4 5 6 7 8. We did 8 solutions in this project. So I think, oh yeah, let me update the number of problems that I did. This is where I like to keep track of the solutions that I did. So we finished up best time to buy, best time to buy and sell stock, and then we also have binary search. Binary search did this, and then we have duplicate numbers. What is this duplicate number? Contains oh yeah, this is already done. So we have merged sort list, sort list. Then we have do sum. We did that. We have valid palindrome. We did here. Palindrome, valid parentheses. Valid anagram is gonna be right here. I like to keep things sorted. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. Good shit. Did 3 more easy program of different type. What is this considered part of this binary search? Stack sliding window, right? How the fuck is this sliding window? I don't still get it. Oh wait, what was the solution again? I forgot. Oh, we're just comparing it, right? We're just comparing it. Okay, I'll have to check this solution out with sliding window, how sliding window is used in here. But yeah, that's it. Okay then, good night. I'm gonna have food, then I'm gonna fap,